Hello everyone. Welcome to the live section for this course, which is Foundation of Classical Electrodynamics. So I'm Gitanjali. I'm a PML scholar from IIT Delhi, and now we are in the last live session for this course. So we'll cover mostly the problems that we have left in the last live session. Mostly, I think we haven't covered the three question of last live session. We'll try to cover it first, then we'll try start solving problems related to the concept that has been taught during this course. So it may be calculation of electric field or the Maxwell's equation or magnetic field, magnetization. So most I will try to cover most of this concept. So let's start our session. So for the first question, so let me ask. Is it fine? The is it my voice? Is it audible to you or it's not audible? Let me know whether it is fine from your side. Can you see my screen and can you hear my voice? Okay. So the first question it's about calculating the average power. So it's like the calculating the average Poynting vector. So there is a electromagnetic wave which is traveling in free space of permittivity epsilon 0, and it is electric field. Electric field is kk p0 cos q x minus ct. The average power per unit area crossing the planes parallel to 4x plus 3y equal to 0 will be. So it's a plane is given, so you need to calculate what is the average power through this plane. So let us draw the plane first, then we'll start calculating the Poynting vector. So it's nothing but a equation of a straight line in 2D. So even we need to calculate 4x plus 3y equal to 0. This can be simplified as so will be. So let us first calculate the B first. Let us see the direction of B, then we'll see what is the orientation of the plane. So B, if you recall, can be written as K cross C by omega. K, it is from the expression you can see it is the coefficient of the position coordinate. So only x is there, so that means K is in the x direction and the magnitude is Q. So K is Q I cap cross K cap E0 cos Q x minus Ct over I cross K, it will give minus J. So B will be minus Q E0 by omega cos Q x minus Ct J cap. Omega by Q or omega by K in free space, you can write it as E0 by C cos Q x minus Ct. So the magnetic field is in the direction of the negative direction of the y. So that means let us see. So if it is B, This is right-handed coordinate system. So B is in the y direction, negative, and E is in the positive z direction. And there is a plane in the xy plane. So this is the plane which satisfies 4x plus 3y equal to 0. So this will be 3. This will be 4. So that means we need to calculate what is the projection of this average power along this plane. So first let us calculate the pointing vector first. So S is 1 by mu naught E cross B. So 1 by mu naught E cross B, if you calculate it, it will be E0 square cos square Q x minus QCT by C J. This will be in the I cube direction. So that means the average value of S will be E0 square to mu naught C I cube. Cos square average is half, so we will get E0 square to mu naught C. So this is the total average power, but we need to calculate what is the power along passing through this plane. So for that, we need to take the projection. So what we can do, just calculate the what is the angle between the, let us say this is NK, which is along this normal to this plate. This angle we can easily calculate it, alpha. So that means the angle between the pointing vector, which is in the I cube direction, this is 90 minus alpha, right? So if you want to find out what is the power through this plane, we need to take the dot product. So this is E0 square to mu naught C cos 90 minus alpha sin alpha. And from the figure, you can easily calculate what will be sin alpha, 4 by 5. So this is 4 by 5. So you will get 2 by 5 C epsilon 0 E0 square, which is, if you look at the answer, there is no answer that is given, is directly given is 2 by 5, right? But if you see 2 by 5 is around 0.4. So zero point 0.5 answer is given. So it will be closer to this answer. So the most possible answer for this question is option C. Negative x direction. So you mean this will be minus I. So E is K and B is minus JK. K cross J will be J cross K is I. So K cross J will be minus I. So I think it will be plus I. So so we have calculated what is the average Poynting vector, which is the intensity, right? Average value of Poynting vector is nothing but intensity. So this is the total intensity that is flowing along the x direction. But here in the question it is asked what is the average power crossing the plane parallel to 4x plus 3y equal to 0. So it's not like we need to this power is given, but we want to calculate what is the power passing through this plane to x. So for that, what we need? We need the dot product, right? So dot product or projection of S along this n cap direction, which is S dot n cap. So this is the plane. If you see this black blue line, it is the plane, and the plane is making an angle alpha with x. So that means the angle between the plane and the x direction where the total power is flowing, it is 90 minus alpha. So you can directly take intensity is E0 square 2 mu naught C cos 90 minus alpha, right? So is it clear up to this? After that, you just take as cos 90 minus alpha, it is sin alpha. Then you can see the triangle. From the triangle, it is this is 3. You can easily get it from this equation, and this is 4. So sin alpha will be 4 by hypotenuse, which is root over of 25 or 5. So after that, what I have done, it's like we are getting the exact answer as 2 by 5, but in the options, there is no 2 by 5 option is there. But 2 by 5, if you calculate, the answer will be zero point 0.5. And the closest answer to this answer we are getting will be zero point 0.5 epsilon 0 C E0 square. I have make a substitution also. I have written mu naught in terms of epsilon 0 C. You have already know this C is root over mu naught epsilon 0. Because the answer is given in terms of C E0 epsilon 0. So you just need to make a substitution. Okay. So is it clear now? Okay. So let us move to our next problem. This is quite easy. This type of problem, I think we have already covered 2 to 3 problem based on this concept. So let us quickly see what will be the answer. So there is a vector potential A, it is given K e to power minus 80 r r k. A and K are constant corresponding to an electromagnetic field. Then it is A is changed to A prime, which is minus K e to power minus 80 r r. So this will be a Gauss transformation if the corresponding change in the scalar potential is. So whenever there is a Gauss transformation of A to A prime, what will be the change in? Okay, so I will wait for 2 minutes. So do you need me to go to the previous page or you are calculating this question? Uh, yes means to the previous page or no? Okay. So Srishti, in the meantime, just calculate what will be the change in potential. First, we need to find phi. Yes. So just recall what is the expression for phi and what are the parameters required to get the value of phi. Okay. So if from the given information you can calculate what is the parameter that is required for calculating the phi, then you can easily calculate the change. So A and A prime is given. Just remember the the Lorentz-Gauss transformation. Then you can easily calculate. Or I think that is also not required because you just need the change in phi. So whenever you make a Gauss transformation, what will be the change in phi? What is the uh, final expression for phi? D lambda by dt, right? So phi goes to 5 prime goes to phi plus minus d lambda by dt. So you just need d lambda by dt value. So that means the value for lambda. So if you recall the Lorentz-Gauss transformation, A is A prime, it is A plus gradient of lambda, and phi prime is phi minus A lambda by dt. So the change in phi, it is minus of d lambda by dt. So we need this value. But let us see what is given to us. So it's given the initial value of vector potential and final value of vector potential. So that means if you take the difference, this value will be gradient of lambda. So A prime minus E is gradient of lambda. So this will be minus 2k e to the minus 80 r. And gradient of lambda, you can write it as tau lambda by dou r cube. So that means tau lambda by dou r, it is minus 2k e to the minus 80 r. If you take the integration, lambda will be minus 2 will cancel with r square by 2. So this will be k e to the minus 80 r square. You know the lambda, so dou lambda by dou t will be k a e to the minus 80 r square. So when you take the negative, because what we need is the negative value of d lambda by dt. So this will be minus ka e to the minus 80 r square. So this is the answer is option C. Just use the information that is given to you and relate the parameters that you need to calculate the potential or the scalar potential or vector potential. From that, you can easily calculate what will be the answer for this question. Option A. So there is a negative sign is there, so that means answer will be option C. Because we need to calculate final 5 prime minus 5. Given 5 prime minus 5, so you need to calculate what is the final minus initial, which will be minus dou lambda by dou t. So this will be the last problem of week of our previous live session. Option A. Good. So the answer for this is option A. So you know the expression. You're still getting A. So Srishti, I think you are taking this. Maybe you are taking this is plus, but the Lorentz transformation, this is minus. If I am not wrong, so 5 prime, the final potential is initial potential minus tau lambda by dot. And the question is asking what will be 5 prime minus 5. So this is minus dou lambda by dou t. So we need to calculate what is negative of dou lambda by dou t. So lambda value, if you see, I think up to this, is this correct for you? If you are you getting the same answer? Lambda value is this, and when you take the dou lambda by dou t, so minus a, it will and there is a minus k also. So dou lambda by dou t is plus k e to power minus 80 r square. So negative will give a negative sign. Yes, after differentiating, you will get plus, right? So this will be plus ka e to power ka r square. Whatever you are getting after differentiating is correct. It's just that the question is asking about what is the change in Gauss transformation of the final potential with respect to the initial potential. So that means you have to take a negative. So negative of dou lambda by dou t. So you are getting dou lambda by dou t is plus k e to power minus 80 r square. So you just take the negative of this because that will give the final minus initial value. So am I clear now? No, this is the value of minus d lambda by. Okay, so you mean you are getting minus d lambda by dt. So I think you are saying you are getting d lambda by dt is a e to power minus 80 r square. But it's not correct. Okay, let me ask up to which part you are getting the answer same to mine. It's like up to this, is it correct? Up to this part, d lambda by dr you will get minus of 2k e to power minus 80 r. Is this correct up to this step? There is a negative sign here. Okay, so I think you have forgotten from here. A prime is given minus k e to power minus 80 r r cube. And A is given, it is plus k e to power minus 80 r r cube. So that means the change in the vector potential, it is minus of 2k e to power minus 80 r r cube. This is the change which is equal to gradient of lambda. Okay. Okay, question number 19 of previous session. I think one of you have already know the answer, but let me briefly say what will be the steps. So it's given the charge inside a material of conductivity sigma and permittivity epsilon at time t equal to 0 is rho at 0, it is rho 0, where A is a constant. Subsequent times what will be rho RT. So it's a conductive medium So that means you can use the expression of J is sigma E, and you know that divergence of E is rho F by epsilon. This we know. So let us take the divergence of F so that we can use this here. So divergence of JF is sigma divergence of E. And divergence of JF is minus of dou rho F by dou T. So this is the rate of change of the charge, free charge density with respect to the time. So we need to use this to calculate what will be the final expression. So divergence of J, it is rho F by epsilon, which is dou rho F by dou T. Now it's quite easy because you know the integration, no? Dou T by sigma epsilon. This is dou rho F by dou. This integration will give ln rho F, ln rho F, and this will give sigma epsilon T. So that means the final expression for this is the first one. I think it's quite easy for you. If not, let me know whether you need any clarification. So for now, let us move to our first problem for this session. So there is a magnetic field. It's a conceptual one. So I would like you to find out the answer. Let me read out the question first. There is a magnetic field in Gaussian units in an empty space, which is described by B is given, B is 0, exponential AX, sine Py minus omega t zk. So what is the y component of the electric field? Four options are given. Option D. Yes, you are correct. So this is quite, say, conceptual one. So you can see the B is along the z cap direction, and if you see the propagation direction, it's along the y direction, right? So in free space, if you recall the Maxwell's equation, so this is K is perpendicular to E, perpendicular to B. So it's a transverse wave. So that means you can't have any electric field component along the direction of propagation, which is the y direction. So that is why there will be no y component of the electric field. Okay, so answer will be option D. Or you can use the formula, like if you want to find out the electric field when you are given the magnetic field. So just use the Maxwell's fourth equation. It is call of phase is dou d by dou t. In free space, d will be epsilon. This is dou e by dou t. Here you can see this is a so k cross h, right? So k cross k is along y direction and h is along Z direction. That means whatever you will get, it will be in the X direction. So there will be no Y component. So answer is D. Okay, so let us see question number 2. So this is based on the method of images. A point charge Q is placed at 00D above a grounded conducting plane. This is Z equal to 0. There are no charges present anywhere. This is anywhere else. What is the magnitude of electric field at 00 minus T? Anyone can recall? So if you recall the method of images, like whenever you have a grounded conducting plane, you can imagine it. You can substitute the system is it's made up of one real charge and one image charge, which is opposite sign and it is symmetrically placed with respect to the real charge. So finding out the electric field, you can make use of two methods. One is to first calculate the potential. So first you can calculate potential at some point x, y, z, v, x, y, z. Then take the derivative dou b by dou z and put the value of x as 0, 0, and this is minus t. So this is one of the method you can use, or you can find out the electric field if you know the force equation, force expression. Finding out the force is quite easy because these are symmetrically placed. So what will be the force? The force will be the distance is 2d and it's attractive force. So this will be minus q square 4 pi epsilon naught 2d square along the kk. And electric field is nothing but just you need to divide it by a charge. So if you divide it by plus q, so this is minus q 4 pi epsilon naught 4d square kk. So answer will be the magnitude will be q by 16 pi epsilon naught d square. Option D. Okay. In any of this method, you will get the same expression, but finding out from the potential, it will take some time. So it's better if you calculate the force first and just divide it by the charge. Okay, so third question based on the electrostatic energy. So for a solid sphere of radius r, these are uniform volume charge density. So electric field expression is given. This is Q by 4 pi epsilon naught r square rk for r greater than r and Q by 4 pi epsilon naught rq rk. This is one of the here. In the next one, there is a spherical cell with a uniform surface charge density. And the electric field of this spherical cell it's given. So electric field is Q by 4 pi epsilon naught r square r cube. So this is for outside the spherical cell because inside the electric field is zero. For this, use the total charge. So what is the correct ratio of the electrostatic energy for the second case with respect to the first case? So if you recall the electrostatic energy, if you look at the solid sphere, so this is epsilon by 2 e square dv in all the space. So outside from r to infinity, this is e2 square dv, which is 4 pi r square dr, plus inside from 0 to r, this is e1 square 4 pi r square dr. So let us take the 4 pi outside, 4 pi epsilon by 2, r to infinity, and there is q by 4 pi epsilon naught. You can write it as beta q, r to power 4 r square dr, and inside this is beta q by r q whole square r square dr. So beta q square will be there. So 1 by 4 pi epsilon naught. So beta, 1 beta will cancel with 4 pi epsilon naught. So you will have q square by 2 4 pi epsilon naught. 1 by r square, integration of 1 by r square dr. So this will be minus 1 by r, minus 1 by r. And when you put the limit, this will give plus 1 by r. And this is 1 by r to the 6 will be there. And r to power 4, this will give r to power 5 by 5. So we'll get 1 by r from here. So this is q square 8 pi epsilon naught 6 pi 5r. This is for the solid sphere. Hollow sphere, it's quite easy because you need to take only one integration. So epsilon by 2 r to infinity beta q r square 4 pi r square dr. And this is quite similar to the first part of this solid sphere. So that means you will get here, or let me calculate it. So 4 pi epsilon by 2 beta q square 1 by r square dr. So from this will be q square by 8 pi epsilon naught 1 by r. So if you take the ratio of this second with 1, what will be the ratio we'll get? Is 1 by 6 by 5. So answer will be 5 by 6. Option D. Okay. So is it clear? In question number 4, there is a charge q which is placed at the center of an otherwise neutral dielectric sphere of radius a. So there is a dielectric sphere and we are putting a charge q here. And this is a radius a. And the relative permittivity is epsilon r. We denote the expression q by 4 pi epsilon naught r square is er. Which of the following statement is false? In first part, you need to calculate what is the electric field inside the sphere of r less than a, whether it is er by epsilon r or the electric field outside the sphere of r greater than a is er, or the total charge inside a sphere of radius r greater than a, it is q, or total charge inside a sphere of radius r less than a is q. So which one of this following is false? Can anyone guess? So it's like there is a dielectric sphere, right? It's there and there is a free charge here. So you need to use of d dot d is q free. So in the first part, there is a electric field inside the sphere of radius r less than a. So for r less than a, we are taking the reason here. So what is the q free charge? It is qf. So d 4 pi r square is qf. So that means d is qf by 4 pi r square. And d for this inside one, so it is a permittivity of epsilon r. So that means you can write this one as epsilon e, and epsilon is epsilon naught epsilon r e, which is qf by 4 pi r square. So that means e inside is 2 by 4 pi epsilon naught r square and epsilon r. In the question it's given, you can take it as a ER. So that means this is ER. So inside we have ER by epsilon r, which is correct. So the first option is correct. Now for the second option, you need to look at the outside one here. So in outside, what is the medium? It is the free space, and total charge enclosed is q. Total free charge enclosed is q free. So that means here the epsilon is nothing but epsilon naught, not epsilon naught, epsilon naught, epsilon naught. So that means we have epsilon naught e. It is qf by 4 pi r square. So we have electric field, which is qf by 4 pi epsilon naught r square, and this is ER. Second option is also correct. Now look at this option C. Total charge inside a sphere of radius r greater than a, it is q. So which is correct? So if you look at outside region, whatever bound charge that will be created due to this free charge, they will cancel eventually. So outside the total charge enclosed is q. Option C is also correct. Now for the option D, it's given total charge inside a sphere of radius r less than a. So we are looking at the reason here, inside the sphere. So for this, the total charge, it will be the free charge as well as the bound charge, which is distributed over the volume. So this is rho B, which is divergence of B. So that is why the total charge inside a sphere of radius r less than a, it is not q. There will be some contribution from the volume bound charge. So that is why option D is not correct. Okay. Feel free to ask me if you have any doubt. Otherwise, I will try to cover because I will try to cover more question today so that it will cover all the concept. So let me know if you have any doubt in between. In question number 5, there is a conducting sphere of radius r, which has a charge q on its surface. If the charge on the surface is doubled and its radius is halved, what will be the total energy associated with the electric field will be? So you are now making q to q and radius is getting half. So energy associated, first you need to calculate what is the relation between the energy with the q and r. So from that, you just use the expression u is epsilon by 2 e square dv. So it is a kind of spherical cell which we have already seen before also. So this will give q square by, I think, 8 pi epsilon naught. Option B. Yes, that's correct. So u is directly proportional to q square by r. Just put the change, we'll get answer is option B. Question number 6. There is a circular loop of radius r which carries a uniform line charge density lambda. The electric field calculated at a distance z directly above the center of the loop is maximum if z is equal to. I think one of you already know the answer. Option C. Let me see. I doubt it is option B, not option C. So let us see first. The electric field expression is 1 by 4 pi epsilon naught Q, which is lambda into 2 pi r, Z r square plus Z square 3 by 2. For maximizing the electric field, we need to take the derivative with respect to the variable, which is Z. So dou E by dou Z should be 0. And if you take the derivative, so this is like 3 by 2 dou Z, this will give 1 minus Z 3 by 2 square root r square plus Z square 2Z over this is r square plus Z square 3 by 2. 2 will cancel 3 Z square square root r square plus Z square. So we will get r square plus Z square as 3Z square. R square is 2Z square. Z is r by root. Okay, so answer is option B. For this type of problem, you just need to know the expression for the electric field. Take the derivative and calculate what is the value. Okay, so this is quite easy. It's based totally on the formula. There is a spherical cell of inner and outer radius A and B. Respectively, it's made up of dielectric material. I think we have already covered this question of polarization PR, which is K by R cap. K is a constant, R is the distance from its center. What is the electric field in the region here? Calculate it and let me know which of this following option is correct. Polarization is already given. So you can directly calculate what are the volume and surface bound charge. Let me see whether you are getting the right option or not. So this will be 1 by r square, dou by dou r square, k by r. K by r square. This is volume bound charge density. For surface one, sigma b is p dot n k. And this is for the inner one is minus k by a. And for the outer one is k by b. We know the bound charge now, so just use the Gauss law to find out what is the electric field. So for ARB, between we have volume charge as well as the surface charge from the inner surface. So P dot A is closed by epsilon naught. Mm, sigma d d plus A2R protein dV. Sigma d dU, this will be 2 by A 4 pi A square plus Q by K by R square 4 pi R square D. So we have so electric field will be 4 pi will cancel and R will cancel. So minus K by epsilon R. Okay, answer will be option. So there is a typo here. This is epsilon of option B. Question number 8. So there is a charge particle which is released at time t equal to 0 from the origin in the presence of a uniform static electric and magnetic field. So these are given is E0 y cap and B is P0 z cap. These are given, and which one of the following statement is true for t greater than 0? The particle moves along the x-axis, or the particle moves in a circular orbit. The particle moves in the xy plane, or the particle moves in the yz plane. So, which of the following option you think is the correct option? So, we have both electric and magnetic field, and we are releasing the particle at time t equals 0. That means initial velocity is 0. So, whatever the motion, initially it will be decided by the electric field. Now, when it achieve any non-zero velocity, the magnetic field also start to act. So, because of this combination of this electric and magnetic field, what do you think? What will be the path? Whether it is circular or in the XY plane, or it's in the YZ plane, or it's moves in X axis. Option A and C. So the particle moves along the x-axis. C option is correct, and the particle moves along the x-axis means it moves in a straight line, which is not true, right? So that means answer is option C. So you have a electric field and magnetic. Electric field is in the y direction. Y, this is Z, this is X, and B is along the Z direction. So initially, the particle will try to move along the y direction, but because when it achieves a non-zero velocity, the B will now act to make a circular motion. Okay, so that means it will now try to move along perpendicular to B. So the path will be cycloid motion in the xy plane. Okay. Question number 9. There is a The strength of a magnetic field at the center of a regular hexagon with sides of length A carrying a steady current I is. So you are given a hexagon and you need to calculate what is the magnetic field at the center. So calculate it and let me know the answer. Yes, answer will be option D. So theta 1 and theta, this expression you already know. This is mu naught I by 4 pi d sin theta 2 plus sin theta 1. Theta 2 and theta 1, these are 30° for the regular hexagon. This is 30, and you need to see what will the perpendicular distance. This you can easily calculate it because this is a by 2. Check it, you will get the d as root 3a by 2. So b total is like 6 times of b. This will give root 3 mu naught I by pi. Okay. So for this question, there is a cube given as This is length L. This is at the distance L from the horizon along the x direction. Electric field is given. This is K root x, x cap. K is non-zero. What will be the total charge enclosed by this cube? Okay, so you got the same. Good. So for this question, calculate the total charge enclosed. Let me know. First, try it first. If you are not getting, then I will help you. Okay, so if it is taking time, let me show the steps. In between, just check whether you are getting the answer or not. So Q enclosed, we need to calculate it. So if you recall, you can make use of the Gauss law, right? So E dot ds is Q enclosed by epsilon. So we need to calculate the flux through this Q. So if you see the expression for electric field, So it's in the escape direction. That means only the DS part, which is uh, direction in the x direction, that only gives non-zero flux. For other parts, it's completely zero. So we just need to take only the surface at x equal to 2n and the back surface at x equal to L. Okay. So for x equal to 2n, or let's say x equal to L, E dot ds is k root x means root n. Ds will be dy dz and it runs from 0 to n. This is also 0 to. So this will give, but for the back surface, the area vector is in the negative x direction, so there will be negative sign minus k root n L square. I'm getting only k by epsilon 0 L to the 5 by 2. Okay, so let us check. So this is for x equal to L. For x equal to 2n, E dot ds is, this is positive, it is in the positive x direction, area vector. And this is k root over x means 2n dy dz from 0 to n. This is 0 to. So this will give k root 2 L to power L square plus half, it will give 5 by 2. So total flux is, one is negative, one is positive. So you need to take the, so this will be 3 L to power 5 by 2 root 2 minus 1. So that means now we know the flux. So charge will be charge enclosed k epsilon naught L to power 5 by 2 root 2 minus 1. So answer will be option D, I think. So is it clear now? So keep in mind the area vector direction. Whenever you are calculating the flux, area vector is always pointing outward. So for the back surface, it's negative escape. So that is why we got a negative sign here. And for the front surface, it is in the positive direction. We'll get a positive flux. You use Gauss divergence theorem. Okay. So that means you have used divergence of E is rho by epsilon. From that you will get rho, then from rho you need to calculate the Q. So I think divergence of E will calculate it. What it will be. I think we will get 1 by root 2x. Okay. Dou by dou x of root x. Okay. So are you getting this one? Am I correct? You must be getting in root 2x. Okay, for the charge, we need to take the integration. This is dx dy dz. But keep in mind, x is starting from not 0, it is starting from L to 2L. And dy dz, it is the normal one, 0 to L. This is L square. Should give the same value, but let's see. So 1 by root 2x, it will give x to 1 minus half to root x, and there will be half, right? It will cancel with this. And the limit is L to 2. I think we'll get the same answer. This is root 2L minus root L. So it's all okay. L to our half L square, it will give L to our 5 by 2 root 2 minus 1. I think the limit was not correct. Uh, that's why you got this other answer. But make sure the picture may be confusing, but it is starting, as I said, there is a distance. It not at the origin. It is displaced from the origin. So here you can see this distance L is given. So is it clear now? Let me draw it again. So there is this cube, which is slightly displaced along the x-axis at a distance x. So it's not exactly at the origin. And it's given this distance is L and the cube is distance L and L. Is it clear now? At least you got the concept, like where you should start. You can start from divergence theorem because it's nothing but the flux Gauss. It is also related to the flux, right? So I've used the flux way, but you can also use the divergence. So can I move to the next problem? Is it okay or you need some time? Okay. So question number 11, it's a conceptual one. So there is a scalar function phi satisfying the Laplacian equation delta phi. Okay, so the scalar function is satisfying the Laplacian equation. So you need to calculate, you need to guess uh, what will be the property of gradient of phi, whether it is zero curl, non-zero divergence, or non-zero curl, zero divergence, or zero curl, zero divergence, or non-zero curl, non-zero divergence. Which one of this do you think is the correct one? It's satisfying the Laplacian equation. Option C, solenoidal e-rotation. Yes, it's correct. Option C is it has zero call and zero divergence. Zero divergence you can get it from the Laplacian equation because it's given it's satisfying the Laplacian equation. So that means This you can write it as delta phi. So that means the gradient, the divergence of delta phi is 0. For the call, you can easily guess also because it's written in terms of some gradient of a scalar. So if you recall, we can write the conservative force in terms of gradient of some scalar. And for that, for conservative force or conservative field, they are irrotational. The curl is always zero. So that is why answer would be zero curl and zero divergence. Okay. Question 12 is quite easy. It's intensity of a laser beam in free space. It's given. It is 150 milliwatt per meter square. The corresponding amplitude of the electric field of the laser is. So intensity, if you recall, for free space, you can write it as half C epsilon naught E0 square. Given this. So that means E0 is 2I by C epsilon. You know the value of C epsilon naught and I. Just put it, you will get the value around 10.6. So I will leave it to you to check. This is also quite easy. It's based totally formula based. Can you let me know the answer? There is a point charge which is placed between two semi-infinite conducting plates, which are inclined at an angle of 30 degree with respect to each other. What is the number of image charge? Recall the formula. So if you let me, so we don't have much time. So let me write. So this will be 360 by theta minus 1. Theta is the angle between this two semi-infinite conducting plates. So it's given 30 degree minus 1. So 11. Yes, you are correct. Of question number 14. So there is a, it's also quite easy based on the boundary condition. There is XY plane is the boundary between free space and a magnetic material with relative permittivity mu r. XY plane, the magnetic field free space is given by Bxi cap plus Bz k cap. What is the magnetic field in the magnetic material? So when it crosses the interface, what will be the magnetic field here? So I think you already know the what is the condition for boundary condition. So if you recall, the perpendicular component of B is continuous, right? So that means whatever perpendicular component is there, it will remain unchanged. For XY plane, the perpendicular component is Z. So BZ will remain as it is. So BZ will remain as it is, BZK. For the parallel component, uh, you can this parallel component is discontinuous, but here we don't have any surface charge. So that means the parallel component is also continuous. Sorry, surface current density. So we have this you can write it as B1 parallel, B1. So Bx by mu 0, B2 parallel by mu 2. So V2 parallel will be mu2 by mu0, which is mu r, and Bx. So the B will be B parallel plus B perpendicular. B parallel is mu r Bx and B perpendicular is Bz cube. The answer will be option B. So is it okay if I skip question number 15? I think you know the answer for this. You know, if you want me to show the steps, I will calculate it. Uh, do you want me to? Let me show it. So there is a solenoid of radius r with n turns per unit length, and there is a time varying current. I is I0 sine omega t. Flows. The magnitude of the electric field at a perpendicular distance r less than r from the axis of the symmetry is. So it's based on the third equation of Maxwell's. So you just need to use E dot dl is minus of dou b by dou t dot d. So E dot dl is E 2 pi r minus dou by dou t of B is for solenoid, it is mu naught Ni. So mu naught n, I is I0 sine omega t in the z cap direction, and dA in the z cap direction, you can write it as 2 pi r dr z cap. So this will give you 2 pi mu 0 and I0 cos omega t. There is omega, and what is left inside is 0 to r, r dr. So this is r square by 2. 1 r will cancel with 1 r, 2 pi will cancel. So we have electric field is minus half omega mu naught Ni naught cos omega t r. The magnitude of this is similar to what we have in question option D. Yes, you are correct. I think you have already calculated. It's good that you are already know the concepts. Question number 16. So there is a constant electric current I in an infinitely long straight wire, which is suddenly switched on at t equal to 0. The vector potential at a perpendicular distance r from the wire is A is given mu naught I by 2 pi k k ln 1 by r plus 1 by r ct square root ct square minus r square. The electric field at a distance r less than r, which is less than ct, is vector potential is given. We need to calculate the electric field. What is the relation between vector potential and electric field? Yes. So you just need to make use of this formula. So there is no scalar potential is given. So that means you can skip that. You can directly this is dou A by dou T. So you just need to take the time derivative of this vector potential, which I think quite easy. So let me show this steps. Mu naught I. So how many questions are left? Two, two, two. Okay, so I think it's better to skip that time derivative. I think you can calculate. I will just let you know the answer. Answer will be option D. Okay, just use this formula to get the answer. Okay, question number 17. There are X and Z component of a static magnetic field in a region R. So Bx is given, is B0, x square minus y square, Bz is 0. Which one of the following solution for its y component is consistent with the Maxwell's equation? This I think you can easily guess because for Maxwell's equation, divergence of B should be 0. So you just need to check which of this following option it's satisfying this relation. Though Bz is already 0, so you just need to take this. Bx is given, so this will give 2x B0 plus 2y By should be 0. 2y By should be minus of 2x B0. Just take the time derivative of all these options. Check it. Check in which part you are getting minus of 2x0, or you can take the integration from here also. If you take the integration, by will be uh, minus 2xy b0, I think. I think option C is the right option. You can check this condition using this all this option or just take the integration. Answer will be option C. Okay, question number 18. There is a electrostatic potential in free space in a region where the charge density is 0. So it's given charge density is 0 and V of xy is given. This is 4 e to the power 2x plus f of x minus 3y square. Given that the x component of the Ex and V at origin 0, 0 is 0. What is the function f of x is? So it's given del v rho is 0, so that means del square v should be 0, right? So if you take the double Laplacian, if you add the Laplacian on v, this you will get 16 e to the power 2x f double prime x minus 6. This should be 0. This is one of the equation we are getting, or you can write f double prime x is 6 minus 16 e to the power 2x. This is one of the condition where we need to check. And other condition which is given is v00 is 0. At the origin it is 0. So if you put the expression, the 4 plus f of 0 minus 0. is 0. So that means whatever function we are having, the f of 0 is should be minus 4. This is 2. And the third is electric field. It is 0. So electric field along the x, it's nothing but minus of dou v by dou x. So if you calculate it, this is 8 e to the power 2x plus f prime x minus 6y. This should be 0 at 0, 0. So if you put the value of x and y 0, this is 8 f prime 0 is 0. So that means the first order derivative at the origin should be minus 8. So these are the three conditions we have. What we can do, you can check one by one which of this following option is satisfying these three conditions, or just take the integration. Okay. So f prime x is given x minus 16 e to the power 2x. So f prime x, it is 6x minus 8 e to the power 2x plus some constant. So this constant you can get it if you put the value of f prime 0 is minus 8. So if you put x equal to 0, this is minus 8 and this is minus 8 plus c1. That means c1 is 0. So there is no constant integration cost. Now just take the next integration to calculate f of x. So f of x is 6x minus 8 e to the power 2x plus some constant z. Similarly, f of 0 is minus 4. So that means this is minus 4. This is, I think, 8. I think this should be 4, right? Because f prime is this 6s. So this is the incorrect expression actually. This will be 3x square by 3x square minus 4 e to the power 2x plus c2. Yes. So put x equal to 0. That means c2 is 0. So f of x is 3x square minus 4 e to the power 2x. Answer is option D. Question number 19. This you already know. Magnetic field at a distance r from a long straight wire carrying current I is proportional to. So this is proportional to I by R, right? R is the perpendicular distance given. So option D. Question number 20 is also quite easy. So there are three charges which are placed on the circumference of a radius r as shown in the figure. Charge q is placed symmetrically with respect to charge q. And if the electric field at the center is 0, what is the magnitude of q? So for this, what you can do, I think you already know how to solve this one. So you just need to calculate what is the resultant electric field due to these two charges, and for this electric field will be in the opposite direction, and you just need to equate it so that you will get the answer. So I'm skipping it for you to calculate. Answer will be option A. This is quite easy. So just calculate it and see whether you are getting the answer or not. Question number 21. So there is a magnetic vector potential which is given by A is 6ik plus yz square zk plus py plus zkk. Find the corresponding outgoing magnetic flux through the five faces, excluding the sedate one of a unit cube with one corner at the origin. So you just need to calculate what is the flux through these five surface without this sedate region. So for this, if you recall flux phi m, it is B dot dA, right? B dot D is nothing but curl of A dot D. This is the flux relation, surface integral of curl of A. Yes, you are correct. So you just need to use this expression. A is given. It is, what is this? 6ik plus yz square jk plus 3y plus zk. So if you find the curl, it's in the Cartesian coordinate system, you will get 3 minus 2yz ik. So this is curl of A, right? So when you take the dot product, that means only that value which is in the direction of ik, that will only give the non-zero value. So that means we just need to consider the front surface and the back surface. By keeping in the mind that for the front surface, the area vector is positive, for the back surface, area vector is negative. Let us see. So phi m, it is curl of A dot D. For the front surface, it is positive 3 minus 2yz dy dz, minus for the back surface, it is negative. That's why we are getting a minus here. 3 2yz dy dz. This is at x equal to 0. This is at x equal to 1. But here you can see there is no dependency on x. And this integration is similar. And there is a negative sign here. That means they will cancel. So total flux should be 0. Okay. So total outgoing flux is 0. Question number 22. This, I think we have already seen in our fourth live session, if you recall, but let me show this text. So is it okay if I skip it? I think you know how to, because there is here you can see, I think we have considered a e to power minus br r square r cube, which is nothing but a e to power minus br r by r cube. A is here is q by 4 pi epsilon naught. Because rk by r square, when you take the divergence, it will give a delta function, Dirac delta function. So that is why when we are calculating divergence of V, we need to be careful because in the origin there will be a delta function. So what we have done is you make use of this vector identity, that this is U divergence of V. So you need to take a vector function here and scalar function. So there are two functions. We can take e to the minus br as a scalar function and r cap by r square as a vector function. So this will give divergence of E. This will be, I think we'll get A gradient of e to the minus br r cap by r square plus e to the minus br divergence of r cap by r square. So this is A minus B e to the minus br. R cap dot r cap will give 1, and this is it will be our 4 pi del q. This is rho by epsilon. Okay, so that means we will get 4 pi del QR and minus B it by BR by R square. And if you see, this is option D. Okay. Question number 23. It's quite a new question. So similar to what one of the concepts that we have seen in the Laplacian equation. So there is a spherical region of radius. There is a spherical region. This is R by 2. And this is centered at the origin of this coordinate system. There are 3 point charges, each of magnitude q, which are placed at one is placed at 0, 0 r, one is placed at 0, r, 0, and one is root 2 r, 0, 0. Which is what is the average electric field over this spherical region due to these charges in units of q by 4 pi epsilon naught r square. So if you recall, we have seen if there is a charge q outside and we have a region where Laplacian equation is valid. So for this is at a distance z. So for this case, if you recall, we have calculated the V average as 1 by 4 pi r square Vd. So this we have seen this will be q by 4 pi epsilon naught z. That means the average potential over the spherical surface, it is equal to the potential that is created by this q at the center of this sphere. So similar to this, in this problem, it's trying to ask what is the average electric field over this spherical region due to some some charges which are placed outside. So similar to this concept, there is a problem on Griffith also. If you look at, I think, problem 3.4. So it's there is a proof given that the average value of electric field, it will be equal to the average field. It is equal to the field that will be created by these charges at the center. So we can make use of this concept. So that this electric field average over the sphere, it is equal to the electric field created by these individual charges at the center. So let's see E1. E1 when charge Q is at 0, 0, R. So for this, E1 is minus Q by 4 pi epsilon naught R square Z cap. For charge E2 at 0, R, 0. This will be E2 is minus Q 4 pi epsilon naught R square Y cap. For the third charge, E3, which is at I think root 2 R 0, 0, the electric field is minus Q by 4 pi epsilon naught root 2 R square X cap. So this is, we are calculating the electric field at the center. The distance are given, or distance from the center is given. So that is why we can directly put the values. So E average now will be the total electric field produced by these charges at the center. So this will be minus q by 4 pi epsilon naught r square half plus this is sk yk plus zk. The magnitude of this will be, I think we'll get 3 by 2 by 4 pi epsilon naught r square. So answer will be option D. Okay. So let us see our last problem. The permittivity of a medium epsilon k omega, where omega and k are the frequency and wave vector respectively, and k has no imaginary part. For a longitudinal wave, k is parallel to the electric field, such that k cross is 0 for the longitudinal wave, and it's given for the transverse wave, k dot is 0. In the absence of free charges and free currents, the medium can sustain. First option, longitudinal wave with k and omega when epsilon is greater than 0, or it is transverse wave with k and omega when epsilon is less than 0, or C, where it support longitudinal waves with k and omega when epsilon is 0, or both longitudinal and transverse wave with epsilon greater than 0. So, for this, first let us see what are the Maxwell's equation when we don't have any free charge or free current. So third equation will give curl of E, k cross E is omega mu naught H. And fourth equation, it will give k cross H as minus omega epsilon k omega E. And it's given it doesn't have any imaginary part. That means this is real. So if you take the k cross E, so that we can write the whole expression in terms of one variable E. So k cross is omega mu naught k cross H. So what I'm just trying to use this in this. So that is why I have taken k cross. So this left hand side, this is k dot E minus k square E. This is k cross S is this. Let us put it here. So this will be minus omega square mu naught epsilon k omega E. Okay, so we have k square E minus k dot E is omega square mu naught epsilon k omega E. This is the general expression. Now let us see what are the conditions that are needed for epsilon so that it can support either longitudinal or transverse wave. So for transverse wave, it's given it should be k dot E should be 0, right? So that means if you put it here, K dot is 0, so K square E should be omega square mu naught epsilon K omega E. That means K square should be omega square mu naught epsilon K omega. And for the traveling wave, this should be positive, right? So that K should have real part. Omega square mu naught is already positive. So that means this should have to be positive so that K square is positive. So that means for transverse wave, epsilon K omega should be greater than 0. For the longitudinal wave, it's given K uh, cross E is 0. And if we put it in the Maxwell's equation, K cross E, it is equal to omega mu naught H, right? So if you put 0 here, so that means H is 0 for the longitudinal wave. H is 0. And second equation, we have curl of H. It is minus omega epsilon K omega E. H is already 0, left hand side is 0, so that means omega epsilon K omega E should be 0. So these are non-zero quantities. That means only term that should vanish is epsilon. So that means for longitudinal wave, epsilon K omega should be 0. So let us see which one of this option is satisfied. If we see option C, the longitudinal wave with K omega, when epsilon is 0. So this is the correct option. For other option, it's given epsilon is greater than 0 for the longitudinal wave, which is not correct. Transverse wave for less than 0, which is not correct. This option is also not correct. So answer will be option C. So this is all about the course, the problems that I wanted to solve for this last lab session. So all the best for the exam. Try to revisit the assignment problem as well as the questions that I've solved during this 12-week live session. So I've tried to uh, keep question from all the types so that you can get a hint of what type of question that can be asked in the exam. Okay. So try to revisit the concept as well as the problems of assignment and the tutorial problem. I will I will try to upload all the I think tutorial for starting from tutorial level. So three remaining slides need to be uploaded. I will try to upload it by tomorrow. So we'll end our live session. All the best, everyone. Thank you for joining the session. So, so goodbye, everyone.